lovely Technical Tuesday. We're talking today about building an AGI supercomputer, ASI supercomputer, and we're joined by the amazing Janet Adams, Sergey Shalyapin, and Teo Valik, and I'll hand off to Janet to provide some deeper intros to this project and our speakers today.
All right, thanks very much, Haley. Happy Technical Tuesday, everybody. Good morning, good evening. I expect it's probably good evening, good night, possibly even good tomorrow morning for some of you out there watching. So thanks very much for following this Technical Tuesdays program, and thanks for tuning in today. Now, some of you may have seen that we put out a press announcement today, just a few hours ago, and I'll ask one of the team if you would please share a couple of those links in the YouTube chat boxes, maybe the Cointelegraph link, a couple more of those links. But it's a super exciting day. And you know, as always, everything we do at SingularityNET, we do it for you. You're the wind beneath our wings. You're our purpose. You're our mission. You're our great hope and optimism for a decentralized future. And thanks to you all and your incredible support for SingularityNET and your vote to put 100 million AGIX into building an AGI ASI supercomputer, that vote, the results of that vote, that support from you and our community is now becoming a reality. We have made our first purchases. Our first hardware is due to be arriving very soon. We're building some very, very strong partnerships, including Teo Valik, CEO of EcoBlocks, and if I'm not incorrect, he can tell you himself, inventor of the phrase GPU and inventor of the GPU, but he'll give you a little of his story. Great honor to work with Teo and his company, EcoBlocks, in the Middle East, who are supporting us. Also, our fabulous CTO, Sergey Shalyapin. Sergey has been probably the inspiration for this whole hardware movement from SingularityNET. Since we first met, we've been working together on hardware solutions. He runs his own data center already. He's been working in advanced, innovative AI and AGI hardware architectures for, I think, possibly a decade or more than a decade. So we're very, very fortunate to have such esteemed technologists here with us, with the history in the space, with the knowledge, with the expertise to design, define, architect, build, and execute the world's first AGI supercomputer, ASI supercomputer, because we're also working with our partners Fetch in their supercomputing and computing rollout. Today's architectures, today's hardware is optimized for neural computing, deep neural networks, LLMs. And we all know LLMs have got some really severe limitations. Just ask McDonald's, who had to pull their chatbot recently for putting bacon on the McFlurries. LLMs have massive issues, and the answer to those issues is neural-symbolic programming, neural-symbolic AI methods, but they require a different kind of architecture. I'm very, very privileged, blessed, honored, overjoyed that SingularityNET, with our partners EcoBlocks and other partners, are at the very front of this AGI race, building the next generation of supercomputing, for neural-symbolic computing, for optimizing LLMs with neural-symbolic methods, for massive concurrency, evolutionary programming, AGI, ASI, and a decentralized singularity for the benefit of all humanity. And it's all thanks to you, our brilliant community, as always. So big love and thanks to you all. Let me hand you over to Sergey, our fabulous CTO at SingularityNET, who's really been the mastermind behind this whole project.
Thank you for your kind words, Janet. Yes, I'm absolutely happy that we are doing this right now. And maybe this is the time from for many reasons. First, it's time just to make AGI and neural-symbolic architectures work at scale, because many years before we dealt with scalar computing for some physics processes, physics modeling. Now, several years we're optimizing GPU supercomputing workflows to be still in the Moore space, and we were doing super simple things, just reutilizing the same kernels, just brute forcing matrix multiplications. We are self-attentional networks at scale, and almost doing nothing beyond this. In fact, that was really useful. Now we can build beautiful memory models at large scale, and in fact, they are almost agnostic to modality. They can be aggressively multimodal and aggressively multilingual in any understanding of language. So any sequence of actions, sequence of pixels, you would just put an image, understand the image as a sequence of lines, lines as sequences, and we just combine them, and we can process images as sequences this way. And we just opening the space of calculating action spaces. We are these models. In fact, we just only start to touch the water here by combining language and programmable reactions and patterns understood like sequences. And that might bring beautiful generalization. But in the end of all, we are still staying in the same constrained paradigm. So we are training something, we just getting a lot of data, we combine this data, we are training something, and afterwards reutilize this something, this body of parameters in inference time. And we're trying to build some beautiful adapters. We're trying to fine-tune these models, and fine-tuning itself was a real big achievement in applied AI world. But still, that's applied AI. That's too simple. So we just optimize big parametric body to be a downstream task solver. And to some extent, it might be useful. And to some extent, we can combine generalization capabilities with the downstream task solving objective, but that's always a trade-off. That's always a compromise. So we just come into to the solution. So whether we make these models too stupid and we constrain them in all of the aspects, or we just leaving them too general and let them hallucinate. The whole paradigm of building the computing in that way is a bit outdated. And at the same time, we are getting to more progressive paradigms like continual learning. We're just staying on the edge of combining beautiful AI techniques and embrace mathematical paradigms which we could put together in AGI stacks with this power of building memory models. And we are coming to continual learning. We're coming to combination of different types of computing process, including not only matrix multiplication or matrix computing, but vector computing understood in a really wide way, combined with scalar computing, taking into account hypervector computing and making use of it, and getting ready to embrace quantum computing and build all these beautiful frameworks embracing different paradigms in advanced AGI level tech stack, and build the system with continual learning ready for self-improvement, and put it beautifully on the hardware we can have regarding the workflows, optimal workflows, optimal workloads, optimal memory management, and just loading it smoothly and engineering it as a whole thing, as a hardware and software complex.
Thanks very much. As an introduction, I wasn't sure were you going to jump in there. Oh wait, you host us.
I just love this. Sergey, thank you so much for all that sharing. It's been so exciting to see unfolding how much expertise we have in this area with the data centers you've already been running and the experiments that you and your team have been doing towards neural networks and the integration of neural-symbolic neural networks. And then to see this opportunity for you and your team to build on that expertise in a really scalable way is it's exciting to see that, knowing that we have a plan. We've been working in this area. You've been working in this area for years in particular, and to see that it's not just, oh, we'll get more hardware. It's like, oh, we know how to hook things together in really interesting ways. We've got a number of experiments we've done at a small scale, and that's really what took LLMs to where they are right now, was the scalability. When we threw enough data, information, training, inference, fine-tuning at it, we got these products that have just wowed and overtaken the world. And now we have that opportunity. SingularityNET has that opportunity to begin building that really scalable infrastructure that can do the same thing with our own methods and experiments, and just see what amazing innovations can come out of that. So thank you very much for that sharing. It's incredibly exciting. And then Janet, sorry, go for it, Sergey.
Yeah, excuse me, I just jumped right to the point, ignoring the introduction. But short introduction might be that way. So we worked on AGI and early applied AI for decades, for many years. And I remember all this process of adapting computing to the tasks we had on the table. We had really a lot of experience. While I remember the times when the biggest neural network processing supercomputers was like table scale, one node, one machine. I always had a farm in my city apartment that was just namely a mining farm, but built for GPUs, which were designed for training neural networks, and each separate GPU was training a separate network. Afterwards, we started to combine it and build beautiful system. We worked on interconnectivity, throughput in really early days, when there was no shared and fundamental technical expertise on that. So we were really early birds in building elegant and computing systems fitting that much. And all this team working in SingularityNET team has beautiful experience, sometimes early hacky experience, and now it's multiplied with the layers of knowledge we have, and with really deep expertise in AGI we have for decades, brought by Ben personally, and the beautiful team which worked on AGI for a longer period of time, like 2 decades, from the point not of computing itself, but from the point of math optimization, and we combine it all together.
Yeah, and it is amazing just how this confluence has worked, where Ben has been developing AGI-ish framework, the OpenCog framework, that gets past scale in some ways just through its multiple intelligences and how cooperative they are. And now we've been building Hyperon for the past years that is the scalable form of OpenCog. It's built to be decentralized, to be scalable, to be something that you can plug into a larger landscape and utilize on a bigger scale, distributed atom space and meta to connect everything. And now we've got Hyperon in alpha. It's ready, it's scalable, and or getting there. We've got our alpha at least ready, and the scalability factors underwriting it. And now we're getting the hardware that enables that scalability to enact. So completely exciting. Thank you very much. And Janet, you wanted to talk a little, introduce Theo and the contribution there.
Well, we met Theo, Sergey and I met Theo over a year ago in Dubai. And I hope you guys, is it okay if I told them that you have this like amazing technical bromance? If you don't mind. Anyway, sorry, I never saw Sergey so excited as he was after first meeting Theo. He was just talking. They were talking and talking hardware and hardware and hardware and hardware for hours and hours. And Sergey said, however deep I go, Theo can go. All the maths, all the deep, all the depths. And that relationship has flourished and blossomed. And we've been very, very grateful of Teo's, both his immense technical expertise, acumen, knowledge, and also his history with the hardware industry, his incredible relationships all around the world with really all of the top leaders in the hardware space. So a year later, it's been a great joy to really fulfill the promise of that early technical love affair between SingularityNET and EcoBlocks and venture out with our first purchases, which we are now going to build into this world-leading AGI ASI supercomputer. So, Teo, maybe a little brief introduction to yourself and your background and how you invented the GPU, if I've got that right. And then let's have a little chat, your perspective on SingularityNET's entrance into the big time, big tech hardware space, please.
Thank you, Janet. And Sergey, and first and foremost, thanks for everybody joining here on the chat. I will make some comments on that Sonnet 3.5 and so on a bit later. For the GPU part, it would be GPU. So I coined the term back in 2002 when Nvidia came out with GeForce 4, and it had a lovely thing called pixel shaders, which were actually register combiners. And I do apologize about going deep on the tech side. But basically, the logic that I had was they have 24 Intel and AMD CPUs have one core. So even though that one core worked on more things and a higher frequency, you had 24 of them. Admittedly, so limited capabilities. But the beautiful thing about the GPU back then, it was basically a 128-bit computer while the CPUs were 32-bit. Now, when I say 128-bit, it means the GPU was doing colors in 32-bit. So you had red, green, blue, and alpha, 4 times 32, 128. And when I kind of started to dabble a little, I was buying into marketing. And then a friend of mine who is also from game development industry said, actually, these are register combiners. So I started to kind of like go down the rabbit hole of what you can do with the GPU. And instead of displaying things on a screen, I displayed it in a text file on a hard drive, which back in the day, I will say it's a little bit complicated. And, you know, just a couple of weeks later, I ended up moving to Silicon Valley and working with Nvidia from the red buildings, which no longer exist today. Working with ATI back then on Metal, which today you know as OpenCL, and, you know, pushing innovation into the industry. And back at that day, nobody ever thought that gaming industry will be a big industry, yet alone the biggest entertainment industry. And nobody actually thought that you could use gaming GPUs for compute. And that led into building my career from one side as media, from another as an engineer, doing very different GPU-related things. Such as supercomputers, and ultimately it all leads to an application, right? Because, you know, from one side, we all talk about, okay, let's conquer the space. We did not know a single exoplanet so a planet outside of solar system, until a student in Germany ran a code which ran 132,000 times, so that's X, not percentage, than their supercomputer that they have. So it is all about enabling this ingenuity of an individual that sees something and then finds a new way how we can create the screwdrivers, proverbially speaking, to do more than screw things. So my career took me basically to developing GPU supercomputers, which were predominantly in Asia. So China, Singapore, and United States. And ultimately that led to democratization of compute. Back at the day, you know, originally I come from Croatia, and, you know, you want to work on computer chips, you had to move to Silicon Valley, and you had to spend your time in Taiwan, China, South Korea, and Japan. There was no Thailand, no Vietnam. I don't want to be disrespectful towards Germany and France, but simply put, leading edge engineers, brilliant minds, they usually don't come from where you think of. They come from places that you wouldn't believe, whether it's an island off the coast in Washington State. Silicon Valley was an orchard 30 years ago. So moving on to more modern things, what SingularityNET is doing, it's not to me to say anything that we're doing, otherwise Janet is gonna have my spine bone and the rest of my hair. But it's all about finding the way how technology can solve a problem. And I'm gonna give you a very straight example. So when you come to Dubai, you basically iris scan your eyes, and after that, you basically don't need to talk to customs officer anymore. Now, for us here, this is, I would say, we come from a privileged part of the world, and this is something that we take for granted. But what about people that come from more, I would say, discriminating or racially profiled environments? And it doesn't matter how good, how well they're off, they will still be profiled. How do you build a technology stack that actually removes our human bias? So these were the solutions that we were working on at EcoBlocks. And in UAE, for instance, your ID, it has 19 blockchains onto it, and it really tries to remove any bias that we as humans inherently, by our upbringing, introduce into life. Now, SingularityNET is solving problems of tomorrow and problems of today. And in order to do that, you actually do need to build the hardware architecture. Today, there is a lot of talk about ChatGPT. ChatGPT journey started in 2013. They didn't have anything running before 2017, and it came out when? 2022, 2023. SingularityNET's path is actually much faster than that. And it's all about how do you solve the problems that people are coming to us? And to address the robot comments, for instance, how about this? You have a 90-year-old lady that has an accident while she had traveled. She ends up in a hospital. She doesn't speak the local language. How do we bring that universal translator from data? SNET has worked on those problems. And in order to commercialize that technology and make it available to anybody, the amount of data that we need to push with neural-symbolic AI, this is not measured in petabytes. This is not measured in terabytes. This is actually measured in zettabytes. And SingularityNET starting the journey and moving from brilliant people around Sergey, brilliant people around Dr. Ben Goertzel, to actually becoming from a technology company into a product solution company is actually solving those problems. Now we have Desdemona, and I hope that all you guys looked into a concert with Macy Gray, that you all looked into presentations and how she's learning. That's a robot which is evolving day by day with every human interaction that she does. And do know that we are referring to Desdemona as a she, right? It's not an it. So building a non-biased, non-discriminatory world is actually designed by, we get people like Sergey, we get brilliant people like Janet, like Dr. Ben Goertzel, and all you guys on this stream, you can actually help us build a better world. Because at the end of the day, hardware is hardware, software is software. But it's the application that we push. That's where the nitty-gritty part comes.
Thank you very much. Yeah, no, it's just stunning sometimes to think about how, as you say, the repurposing, the reuse, the seeing technologies or opportunities in new lights can be so transformational. And I reminded of the Archimedes invented the screw and steam power, and yet we didn't have steamships for hundreds of years at least, right? Nobody put those together. So seeing what the GPU is capable of, that's being advanced for games and other technologies, and then applying that to large language models, how innovative, and to be the person who saw that, or applying math in fresh new ways, as we're seeing with AI, with encryption, with quantum, and making it really applicable is amazing. And to have some of the most brilliant people on the planet working with SingularityNET, working at SingularityNET and with SingularityNET, to make these into real human progress that helps people in real situations, it's just incredible to be on the forefront of all of this innovation, all of this development, and all of this benefit to the world, to the planet. So thank you very much, Theo. It's so exciting to have you here today.
Right. Thanks, Theo. Incredible. Thank you for your very, very kind words and your immense support for the SingularityNET ecosystem and the beneficial singularity. Now, guys, this is Technical Tuesdays. Let's get technical. What are we buying?
Okay, so essentially, this is the first generation, and we actually worked on it for a bit over a year. So with EcoBlocks, what we basically do is we do modular data centers. So this is a standard shipping container, 6 or 12 meters or 20 or 40 foot in length, times 10 times 10 or times 3 meters. And basically, we can put about 1,000 GPUs to keep things light in a single container, which is a tier 3, tier 4 certifiable, and it can be deployed next to any telco tower in the world. That also means it can be deployed next to solar panels. It can be moved in and around solar panels as you increase efficiency. And most importantly, it can be put very close to underwater internet cables. So the challenge with data centers today is you build a huge building, you spend a ton of concrete, and quite frankly, you can never offset that carbon emissions, and not just carbon emissions, we talk about all the other negative impact on the environment. These products that we use, even the batteries themselves, are 98% recyclable. So what we are building with Singularity is literally a fully, I would say, redeployable ecosystem of compute, which was done together, designing it with our partners from ASUS and GIGABYTE, working with silicon vendors such as AMD, Nvidia, and Tenstorrent, and I will address each and one individually. So in essence, the first generation, we're talking about CPU and GPU servers, which are going to be serving the creation of neural-symbolic AI, AGI, and a path towards ASI. So this is a multi-year journey. And I think we can be very grateful that ASUS, GIGABYTE actually started to work together with SingularityNET team to build tune hardware for Singularity. And we're getting the same feedback from AMD, from Nvidia, and from Tenstorrent. And coming forward, you're going to hear a whole lot more about how OpenCog, which as its name is an open standard, can actually be a brilliant platform for that world of tomorrow that we're building. And when you take a look into all the applications which SingularityNET ecosystem companies such as Arca are working on, you're going to see quite a lot of innovation and, more importantly, quite a lot of focus of the industry now moving towards SingularityNET. And that, I think, is the most important part, because at the end of the day, how you impact the environment, how you impact the ecosystem of silicon, that is how you actually change the world. And nobody said it's easy, it's really hard. And this is why a brilliant team around Sergey is working on developing.
Thank you very much. Yeah. like what you're pointing at there, and how we can be working with big partners, we can be building, we can be joining kind of a different level of game, and we can be actually implementing our ethics, be flexible, modular, and actually taking advantage of. There's so many growing opportunities in technology, both in green technologies and in compute technologies, and to be able to be flexible enough to take advantage of them is really an amazing opportunity. It fits the decentralized ethos of SingularityNET ethically and in a decentralized, modular, global way. So thank you.
Thank you. Thank you. And what I often say to people when I'm just speaking about this is that it's like, the race to AGI is a race. It's an actual race. It's not a hobby. It's a race. And hitherto, I'm utterly convinced that we have had the best scientists, or in the analogy of the race, let's call it a Formula One race, the best driver, the best engineers, the best strategists. But we've been out there on that racetrack without the hardware, without the kit, without the Ferrari, or whatever is the best car on the racetrack today. And so now with this hardware, there is actually nothing to stop us winning the AGI race. It's a huge win for SingularityNET, for ASI, and it's a huge win for decentralization. It's a huge win for the decentralized AI movement, the decentralized AI community. Well, the question is, and I think what our audience would really want to know, and Sergey, you can maybe help us with this one. What kind of hardware does AGI need, and why is it different?
Yeah, thank you. This is a really good question. And in fact, I would say we don't have a final answer right now. But our answer is much better than anyone could have right now. We are looking from AGI Research Hill, and we see the landscape really, really well. And just we are just sober enough to understand that AGI is such a big thing that we maybe don't see it in all the detail. But anyway, generally, we can put it that way. What is AGI? What AGI is in technical terms? First is a novel technology stack. It's a different combination of technologies and of frameworks and of programs, same in like general terms. On the second part and different angle to look at AGI, that AGI is a workload. That's a dynamic computing process. And we also can understand it like a dynamic computing process and see what needs this dynamic computing process might have. And the third angle to look at this is AGI is ecosystem. I will try to answer all of these three questions and to get it to the ground, what type of compute we need and what type of compute we're gonna have on the practice. So from the point of tech stack, AGI deals with different types of memory. So we will utilize knowledge graphs extensively because AGI needs to deal with explicit representations in comparison to dealing with implicit ones. So AGI is a white box. In fact, that's all the general framework of processing symbolic algorithms needs these explicit representations. And at the same time, we need explicit representations to run reasoning, to run multi-chain reasoning, and to run real logic. So generally, as a technology stack, AGI is a wide family of algorithms. It can operate black boxes as memory arrays. and these black boxes need to be retrained dynamically in retraining cycles, so we can operate them as neural networks or specific neural networks adapted to work as a part of family of symbolic algorithms, and we will operate dynamic metagraph and hypergraph representations. That's from the point of technology stack. In fact, it's even more complex because we have probabilistic logic there, we have pattern matching done at scale, and we are moving, in fact, from the paradigm of training some math model and afterwards reutilizing this model in inference mode. We are coming to the process of, and usually when we train in the model, we just solve discrimination task, and we are talking about generative AI, but these models are just discriminate, but they are classifying what's the next token in the vocabulary would be the most probable one. So they just choose one unit from the vocabulary, nothing else. We're still dealing with discriminative AI, but even moving far from discriminative and generative paradigm, we are moving towards the process of knowledge distillation and pattern matching and mapping at scale. These are two different processes which we will have instead of discriminating and generative approaches in the computing process. That's what we are getting on the level of processes. And also we are moving to continue learning with this, because in the paradigm of continuous knowledge distillation and continuous pattern matching, we are moving to really complex and non-trivial joint learning frameworks. So we almost don't have some entities to train them. We will have them as specific internal task solvers, but there will be no downstream task solvers, and the best utilization of these models would be solving some specific task to work with the distilled representations. So they will solve some abstraction functions, and that will be maximum of optimization of parametric bodies we utilize as I don't know, that's as optimal functions to be a part of a continual learning process. That brings us to different demands in memory and different demands in supercomputing frameworks. So in a supercomputing framework, we need a network with lowest latency possible, combining these different computing paradigms. It's completely not enough just to interconnect computing cores which do the same monolithic process like matrix multiplication at scale. In fact, with self-attention networks, it's not absolutely monolithic, and we need to do several operations. We need to store activations, we need to store gradients, we need to, it's a more complex process, but still it's a monolithic workload. In AGI, we have absolutely heterogeneous workload, and we need experimentation with this. We need to understand how to calibrate these processes better. But what we can do in terms of building the most beautiful hardware, we can think about it like explorers, like artists of engineering. We just put all the optimal systems we need to the same framework. That's what we are doing, to the same network with the same speed. We just we compute maximum load any compute unit can give us in terms of specified dedication of which types of compute we do. For example, scalar operations or vector-based operations, different types of operations. We optimize all the nodes, and afterwards we will calibrate it on the level of supercomputing framework, which type of compute nodes, dedicated compute nodes, or which type of memory dedicated nodes we will have. That's the first layer of calibration and optimization. We will do it on the level of supercomputing with different computing workloads in a complex AGI class frameworks with the continual learning processes we will have there. And but also we need to begin this with the classical workloads. So I wouldn't just hide that we need massive GPU compute and matrix multiplication, because we need to be competitive in the LLM space also. And there are a lot of tasks we need to solve there, and we have beautiful ideas coming from this AGI and this understanding how AGI should work. We have a lot of ideas how to train these memory models better, much better, and we will definitely do this. We will utilize this power also for this workload, but I think that would be a minor part in our case, because we're thinking bigger, but we also need to be competitive. We need just to be competitive in all the layers of AI, including this intermediate layer and neural-symbolic AI layer and complete AGI architectures. And we need to go down, and we need to deal with applied AI on any scale and get back quickly. So these systems will be absolutely powerful for the all variety of tasks. And here we come into the ecosystem, to the last part. From the point of ecosystem, AGI will be a non-trivial thing. That will be a decentralized algorithm, which lives in the network. Maybe not exactly now when we are building the tech stack itself, but we're looking forward that compact but really powerful AGI nodes, like Hyperon nodes, for example, will be distributed across the network. And even in cases we will have big latency, that will be really useful. So we can think about it as a heterogeneous computing network with different latencies and different speeds of interconnection. And some tasks could be solved they can take longer. We can wait for solving these tasks, and this process would be really elegantly calibrated in stack. So we'll have really dense interconnection for some kind of nodes, but we will reutilize widely distributed systems of compute and memory also in a really efficient way. We will just take into account different latencies, and that how it will work as an ecosystem. And we're also considering that these supercomputing nodes that would be quasi-centralized pieces of the systems will be pieces of a wider decentralized network. And this is really important to understand right from the beginning.
Thank you for a very thorough run through on all of that. It's such a huge picture to hold. You know, the short term looking at LLMs and the neural-symbolic, the long term looking at more complex AGI, and then the in between, how we get there as well. And of course, I think the biggest takeaway here is that AGI is a non-trivial thing. So if we hadn't noticed that before, we have noticed it now. I definitely want to dive into with you more, Sergey, on continual learning. I'm so curious, but that's not the subject for today's Technical Tuesday. So another time we'll dive in there. I wanted to ask first, if I may, there was a question from Growpool looking to hear some of the technical contrast between building the HPC, the high performance computing clusters like this with SNet communities like HyperCycle, building out the democratized decentralized network infrastructure with the same aims. If you could speak to that question.
Okay, so to jump in, so first and foremost, we have a little bit of experience in terms of supercomputing, and the biggest supercomputer that I helped design had 40 million cores. So it's definitely a non-trivial item, and we're talking about 2014. And it was world #1 for about 2.5 years. Now, Singularity's challenge is a little bit different, because what happens when you build hardware that can evolve? All you guys and girls here at the call, you probably, whenever you hear any news about new supercomputer, new AI, blah, blah, GPU. Actually, knowledge graphs are extremely CPU intensive. So what SingularityNET is actually buying and designing is a hybrid. So just like the name of the whole movement is decentralized AGI, a move toward decentralization, the hardware is actually heterogeneous. So be ready for some hardware porn right now. So we have AMD EPYC current and next generation. We have Nvidia H200, L40S, and Blackwell, aka GB200. We have Tenstorrent Wormhole as the current generation, plus the next generation hardware. And the next generation hardware will actually be a little bit optimized for SingularityNET. There, I said it. You're free to kill me. Janet, I owe you dinner. But this is building an evolving system. So when you design a supercomputer, you're limited by the applications which are going to be running on it. And here is where you have to build compromises. You guys are right when you mention, hey, we have NuNet, we have HyperCycle, we have OpenCog, we have SingularityNET ecosystem. So how do you actually build hardware? Well, we are working, yes, in terms of networking, we have InfiniBand, but we also have Ethernet, actually several of them. So the very first implementation of intelligent networking will be on SingularityNET's supercomputers. I mean, we call them exacontainers, actually, because this is exaflops of compute in 12 meters. And this is exactly the density that you can hit. And then depending on the workload, let's say NuNet needs this, OpenCog needs this. By using AI-defined networking, AGI-defined networking that Sergey and the team are going to be optimizing, and we are all going to be optimizing, we can dynamically allocate resources based on how hardware is actually being utilized. So hardware-wise, we have AMD, current and next generation, Nvidia, current and next generation, Tenstorrent, which is an open source hardware and software stack, current generation, next generation. So if we are to build AGI, if we're building a path towards an ASI supercomputer, to stay on point because this is Tech Tuesday, building an AGI supercomputer, it's all about building something which is flexible. And at the same time, let's say that NuNet goes one way, HyperCog goes the other way. Well, the hardware itself is designed to handle both variations. This is not a one-trick pony like LLMs. This is leading towards LMMs. This is leading towards all the crazy cool applications that you guys have been enthusiastic about it. And Maurus, yeah, 10 gigabit fiber Ethernet, that's kind of like a standard. And then a few of them, and then a few of them in the multimodal node. And then linking SingularityNET's clusters all around the world into one decentralized supercomputer. So this is going to be a crazy, exciting journey. But the most important part is SingularityNET is now a partner, not just a customer, to leading hardware vendors. And over time, it's going to have a significant impact and influence on what these multi-billion, multi-trillion-dollar companies design so that we can bring decentralized architecture to the market. And I think that is the most important message, guys and girls here. It's, and just to answer Nick, in terms of power energy requirement, so a standard data center in the Middle East has a PUE, so that's power efficiency utilization, of about 1.5. Which means for every 1 megawatt of compute, you basically spend 500 kilowatts or 50% on cooling. At EcoBlocks, we design things that in the middle of desert heat, we're running PUE 1.2 in the middle of summer and PUE 1.1 in the winter, actually even sub. So can you imagine what, if it works like that in the Middle East, what is going to work in North America? How it's going to be operating in Northern Europe, how it's going to be operating in Asia. The key thing is to deliver the compute wherever it's needed. Not we're going to put some ivory tower in the middle of nowhere, and then when you need the real-time response. Because here is the thing. Cloud compute, yeah, it's all wonderful, sexy, and so on, if you can live with the 1 second delay. But when Desdemona talks to a kid, Desdemona talks to a kid, she cannot wait 1 second hop here, 1 second hop back, because the kid is going to look into the robot and what now? No, this is all about enabling near real-time communication. So this is what this hardware is all about, and we look very much forward building a lot of crazy applications and working with Sergey, Janet, and the whole SNET ecosystem.
Thank you very much, Theo. Yeah, what you mentioned, the fabric of decentralized compute, right? This is what we're building with NuNet, with HyperCycle, with this compute structure. HyperCycle has a great layer for payments and decentralized compute assignment. NuNet has a great fabric layer for how to utilize resources in a distributed way. SingularityNET has OpenCog Hyperon and ways of using distributed atom space on top of or with and alongside these or by itself, and then having our own hardware to run that on, to train that on, to build that on, that utilizes these layers and build this fabric of being able to interact everywhere in real time, continual learning and real-time responses from the robots is amazing and exciting. Thank you very, very much. Sergey, did you have something that you wanted to add to that?
There are a lot of things to add here, but you know, the most intriguing, it's putting different heterogeneous components together for me. Yeah, and also I see like several layers of mapping.
I think we lost Sergey. Give us just a second. There he is. We lost you for just a second, Sergey. Are you back?
Oh, excuse me, please.
Yes, thank you. We can hear you. But may not be able to hear us.
Well, just while Sergey's recovering his connection there, interesting questions coming in on the channel. Nick made a very good point. Nick, it's amazing to have you here at SingularityNET. Anyone who doesn't know, Nick has joined us as Chief Product Officer and is making a huge difference already. So welcome, Nick. So Nick asked, Sergey, what are the metagraph implications for lower cost distributed compute while preserving privacy, increasing trust, and fostering open governance? Some great questions there from Nick, if you're back, Sergey. And also we want to hear you finish what you were saying previously, if you're back. No, we seem to be having technical difficulties. Theo, did you want to jump in and comment on any of these topics, chip co-developments, Simuli or partnership?
Well, actually, it kind of leads into answering the question before. I mean, look, guys, there is a lot of like fears, you know, what AGI or ASI is going to do. You know, at the same time, you know, we had a lot of fears about phones, and you know, today everybody uses a computer in a pocket, and it's your wallet, and it's your everything. Now, what happens when you actually bring something to be as seamless as possible? Because we're all technicians. We love to talk about technology, but what it actually does for us people. So the quality of the data itself is the key thing in making AGI usable. So right now we're all limited, quite frankly, with the inputs that we're putting in. You know, you can buy a $2.5 million hypercar and it's going to have the same parking sensor as a $10,000 car. So we need to do better in terms of what hardware we actually use and what inputs we put. So Singularity, and this is, Janet made a very right point. SingularityNET is embarking on a journey to work with hardware vendors to create optimized chip architectures as well. And this is a humongous task, and it's going to take multiple years to fulfill. You know, just to let you know, a chip design time from Ideation to actually design lock is about 18 months. To tape out, it's about 24 months, and qualification is about 12 to 18 months. So anytime you want to design an AGI chip today, like Simuli and going beyond that, it's a 5-year journey, and you never know what is the right and what is the wrong move. But once that it's out, it evolves. And this is the main part, right? Evolution. The hardware that Singularity acquired, is it decentralized? Yeah, but it is decentralized in a little bit of a different space than what is in our industry known as decentralized. Because in our industry, we call it decentralized tokens and so on, yet 87% of all tokens run on Amazon, AWS. Is that decentralized? Is a 1-second delay decentralized? Because it can be interjected, interrupted, and you can put something inside. So when it comes to developing open source platforms, developing decentralized platforms, protecting individuals' data, it starts by controlling your own destiny, which means if you don't own your infrastructure, you're at the mercy of somebody else. And quite frankly, the amount of times that I heard a startup that has an amazing idea and a POC for 1,000 users work, then gets adopted by a big company, telecom or something like that, comes to market, you have 10,000 live users, and the thing crashes. SNET is doing products for platforms for 8.3 billion people. And this is a daunting task. Don't take that lightly. We're talking about past zettabytes, actually. We're talking about into yottabytes. Now, can you do a yottabyte computer today? No. But in 10 years, if we add the zettabyte per year and then have the standard Moore's law, yeah, we will get to there. And then we're going to have better products and better platforms. But that journey starts by taking the control of your own destiny. And this is what SingularityNET has done. It has taken control of its own destiny by establishing partnerships with ASUS, with GIGABYTE, with AMD, with Nvidia, with Tenstorrent. And you're going to have quite a lot of announcements, which are not up to me to say anything. But guys and girls, we are on incredible journey, and it's only starting now, actually.
Thank you very much.
Yeah. And just for all those people in the audience watching and following who are always excited about our partnerships, I should just mention that these partnerships are all under discussion at this point in time. But watch this space. I'm sure there'll be a lot of fantastic news to come. And we're getting a very, very warm reception everywhere we go. All of the hardware companies we speak to, they want to be part of the future, and they want to be part of designing the technology hardware infrastructure for the future, not just for today. And so we're really grateful to Theo and DecoBlocks for all your fantastic introductions right at the very, very top of the hardware industry. Haley, I think we are close to wrapping up. We seem to have lost Sergey. I think possibly just bringing it all back together again, and delighted to see, what was his name, here from Fetch. Delighted to see the Fetch community coming into our SingularityNET events. We are definitely, together we are definitely stronger. I'm just looking at this guy's name, Runner, was it Runner? Anyway, hi to you, and thanks so much for joining us. And so Fetch.ai also announced a major investment into hardware earlier this year. And of course, together we are stronger. The whole purpose of this ASI Alliance is that SingularityNET, Fetch, and Ocean can together tackle big tech. And the more compute we have, the more hardware we have, the more collaboration we have with Fetch agents, with Ocean Technologies, the faster and the better our chances, the faster we're going to win this AGI race and dramatically change the big tech dominance and tackle that big tech dominance. So yes, this is an ASI initiative. It's at ASI level, and we're working very closely together with Fetch and Ocean on all of this.
Thank you so much, Janet. Yeah, thank you so much for joining here today, for diving into this. We didn't get to answer half of the questions that the community had, much less our own topics. We didn't get to dive into the HPC clusters. We didn't get to dive into, Nick had a great question also on energy and green usage and how that affects decentralized processing. But we hope to answer more of these.
Can I just touch on the energy and green usage?
Of course, yes.
Theo can comment on the sustainable water cooling, the sustainable energy sources that we're working with. But a really, really, really super important point is that neural-symbolic AI and AGI compute will require less compute resource than straightforward deep neural network processing. So we are already moving in a direction that is healthier for the planet and building a better future for all of our children and our grandchildren and every other species on the planet who needs to thrive.
It's amazing how the neural symbolic architecture, by going beyond just the neural that's been so heavily developed and invested in lately, takes us beyond some of the problems of hallucinations as we've pointed at, but sparse data and entire vertical markets with sparse data, as well as just by bringing in a more focused, more intelligent cognitive architecture. We get beyond many of the problems more efficiently just by having a stack that is more intelligent by design rather than just throwing a lot of compute at the issue. So yeah, thank you again very much, Janet. Thank you very much, Theo, for being here. Thank you, Sergey. Unfortunately dropped, but it was an amazing conversation. We absolutely will share more about this because there's so much interest. It's so important to the future of SingularityNET, AGI, ASI, the ASI Alliance, and how we're building out this next level, next stage of development, how everything is coming together with Hyperon development, the Hyperon Alpha, the software stack, the decentralization stack with NuNet and HyperCycle, and then our actual hardware, decentralized hardware stack, modular, flexible, energy efficient, and very exciting, designing all this next generation, next level processing that will take us into the next era. So thank you very much all for joining us here today. Thanks for staying a little bit late with us. And we look forward to having more of these amazing conversations in the future.
Thank you, Hayley. Thanks also to Theo and all of the team at EcoBlocks who have done a truly wonderful job in getting us to this point. Thanks so much to our community. Runner Rabbit, that's our new joiner from Fetch. Thanks very much for joining. Thanks to our old friends. I see many old friends here on the audience and many new friends as well. Onwards and forwards to the singularity.
Thank you very much. We'll see you next time.
Live long and prosper.
Oh, Sergey came to say goodbye.
I missed several minutes, but thank you and sorry for that.
Oh,
Thank
not
you,
at all. Did you have any closing comment you wanted to make now you've made it back? No.
or we'll use it as an excuse to bring Sergey back again to discuss all this.
Yeah, we need to put
Thank
Sergey
you very
on
much.
that hardware network as soon as we possibly can. Thanks, everyone. Bye.